Now the topic is instability of lyophobic colloid. Now the topic is instability of lyophobic colloid. In this, we are going to study about in the DLVO theory. In the DLVO theory, we have studied about this like primary minimum, secondary minimum, and this is net repulsion or net charge what we can get from this upon the combination of repulsion and attraction. Here the particle surface is there. This is about the particle surface. And these are the distance between the particles. This is the distance between this one particle surface to the this is the distance between one particle surface to the another particle, and this is the distance between this particle one particle surface to the another particle. Primary minimum, secondary minimum. In the primary minimum, what will happen means no charge is there. In the primary minimum, no charge is there. The particles will combine and their atomic orbitals get interpenetrated. Their atomic orbitals get interpenetrated and leads to the primary minimum like this. Here in the secondary minimum, the particles are just at 1000 to 2000 distance. The particles are at a certain distance, leads to the formation of floccules like this. Leads to the formation of floccules like this. The particles are just aggregated like this. So in the colloidal dispersion, in the colloidal lyophobic colloid, what will be how the stability of lyophobic colloid means? This is the lyophobic colloid. These are the lyophobic colloids. The colloids get negative charge means whenever you put lyophobic colloids, though having charge, this lyophobic colloid having positive charge, whenever you will keep this lyophobic colloid having positive charge in the solution, in the solvent, then electrolytes, what are the electrolytes present in the solvents get absorbed. What are the electrolytes present in the solvent like water get absorbed on the lyophobic colloid having positive charge. So negative charged electrolyte get absorbed on these particles. So whenever the absorption of negative electrolyte, negative charged electrolyte, there is a repulsion between these two particles. Due to the presence of repulsions, the particles are in the separate, like when they are coming, they will become repelled and they will go far away like this. So this entire system gets stabilized, means the colloidal system gets stabilized due to the presence of negative charge that are absorbed, means due to the presence of negative charge, due to the absorption of electrolyte on the particle, on the colloidal, on the lyophobic colloidal particle. So repulsion between the particles due to negative charge present on the particle by the electrolytes leads to the formation of stable colloid. When this particle are coming this, and due to the repulsion they will go back and they will always in the Brownian motion. Due to this, the entire system get stabilized. See what will happen. See, I have removed at primary minimum. At primary minimum means the distance between the particle is very less. When at this position I have removed the electrolytes present on the particles, whatever the electrolyte. Initially like this. Initially these are like this. When I have removed the electrolytes, this is the electrolyte, you can assume. See, initially this is like this. When I have removed this electrolyte, then the particles become closer and closer and leads to the penetration of their atomic orbitals at primary minimum. Leads to the penetration of atomic orbital of those two particles, and the particles get aggregation. The particles are aggregated. At primary minimum due to the interpenetration of their atomic orbitals. Then I have removed this. See, this is initially this is like this. Initially this is like this. When I have removed this one, then there is a aggregation, means interpenetration of atomic orbital leads to the instability of the colloidal dispersion. See, here what I have added means this is the initial stable system. Initial stable due to the presence of this electrolyte. This will produce the negative charge, means this will make negative charge to both these particles. Due to that negative charge, repulsion is there, the entire system gets stabilized. It leads to the formation of stable colloidal dispersion. If I will add excess colloid, what will happen? See, if I will add excess colloid, what will happen means the particle size increased. The particle size is increased due to the absorption of excess electrolytes. Particle size is increased due to the absorption of excess electrolyte, and the particles get aggregated. What happens means when you add excess electrolyte, then all the negative charges makes the particle to be neutral. All the particles make this makes this colloidal dispersion to the neutral charge. Whenever the neutral particles get aggregated. The particles are aggregated. Whenever the aggregated unstable colloidal dispersion. Here also unstable colloidal dispersion upon the removal of electrolyte leads to the aggregation of the particles, leads to the unstable colloidal dispersion. Upon the adding of excess electrolytes leads to the particle aggregation only, and the system is unstabilized. When you will add the electrolyte opposite charge to the electrolyte, means this is, for example, you can consider this is chloride ion. I added the sodium positive charge. Then the sodium, the interaction between this ion means the chloride ion and there is an interaction between, or there is a formation of bond between chloride and sodium, means I have added the cation which is opposite charge to the adsorbed which is having opposite charge to the adsorbed electrolyte. Opposite charge to the adsorbed electrolyte leads to the aggregation, means formation of bond between sodium chloride and sodium chloride. Then there is a removal of the electrolyte. Then this remove electrolytes, then again the particles get stabilized. Particles get aggregation. Again unstable. See how many times? 1, 2, 3. 3 times. 3 unstable. 3. So how can we make unstable to the lyophobic colloid? Means by adding the opposite charge electrolyte to the adsorbed electrolyte. By adding opposite charged electrolyte to the adsorbed electrolyte. Next one is the excess electrolyte. Excess electrolytes leads to the complete neutralization of charge, leads to the particle aggregation, unstable only. Removal of electrolyte. Again removal of electrolyte, due to the spontaneous speed movement of the particles, they will stick like this. The particles get stick and their atomic orbitals get interpenetrated at primary minimum, leads to the unstable of lyophobic colloid.